afternoon, everyone. I'd like to start my talk. I'm going to be talking about computational intelligence, how we can drive better decisions from data, and the story that we at Wolfram have been involved in for coming up to a third of a century, but it wasn't called data science and when we started. And the issue is how to get the maximum value out of the data we've got, and how intelligence, computational intelligence, can really achieve that in a much better way than we've been doing so far. Question one might ask, since we've all had mass data, has it led to better decisions? It's not as good an answer as one would like. One would like to say one's got so much more data and the decisions have become so much better in life. But it's not been quite as good as that. And the question is, why not? It's not like we don't have enough data to play with. It's that we can't get the insights sufficiently from that data. Another way to put this is your data maximizing your return on investment? And I think the answer for most people right now is no. So a typical challenge for today is how do we get from available data to accessible data? There's a difference. The data may be there and available, but can you actually truly use it for decisions you want to take? Same sort of question, can we get average data and turn it into personalized? We want answers specifically for the questions we have individually or as organizations. We don't really care about the average answer for everyone. And this is particularly an issue when the complexity of the data is becoming so much greater and the volume of it. So we've kind of got to, it's like looking for a little twig in a big forest. And the question is, how do we do this better to actually achieve real answers? So I think the answer to this question is sort of smart automation around computational intelligence. How can we drive more intelligence using the power of high-powered computation for everyone, not just for a few people, but for everyone in an organization at the level in which they operate? And another part of this is how can we get the people set up to do a better job of interacting with this new AI age? Not straightforward. We all need to learn different things to be optimized to handle this. I want to spend most of the talk talking about the technology, and we'll loop back to the people at the end. So what's the trick to unlocking, in a sense, the highest level, insightful computational intelligence for everyone? What is it that can allow us to continue to unlock that? Well, it's a complicated question, I think, but the impetus is to start from the interface. If you think of different levels of people in organizations, there are very techie people who want to interface at a very programmatic level often. There are people who have no interest apparently in data science who want to interface at a much more straightforward level. And the question is how to optimize all of those simultaneously with the back end of the data we have. So let's talk about types of interface. So I'm going to do a linguistic query. I'll try and do it on my iPhone. It's a bit noisy. And I'm going to ask population of the UK versus sheep in New Zealand. And if Siri is willing, and it is, that's good, I'll just show you on this. You can see that Siri took my question and it basically queried it, and we computed an answer with our Wolfram Alpha engine. So if you ask Apple a computational query, if you ask Siri a computational query, it will come back and use Wolfram Alpha to produce the answer. So it's pretty cool there that what I've managed to do is, in a sense, compute a fresh answer by talking to my phone. So that's a kind of interface to data that you sometimes need. Not always, but sometimes. And of course, I could type that in. There are much more straightforward ways to do that directly in our Wolfram Alpha, but I thought it would be nice to show it actually coming off the phone. Here's another style of interface, what I would call a knowledge app. So this is a thing that it's just an app, but to produce an answer, it might be a report, but actually you might want to just literally play with the data. So here I'm playing with what happens in, this is in fact the heart disease risk of a whole Middle Eastern country, and I am querying it live to see what the result is of changing, in a sense, the age of the person I'm looking at and so forth. So I'm getting personalized answers direct from the data. And the trick here is to make those apps sort of easy enough to build. So another kind of thing we might do is what I would call linguistic programming. Let's just ask a question here. Ooh, this seems to have made a mistake here. Let me see if it's happier with this. Might be because I'm not on the internet properly here. Oh, there we go. Okay. So we've got, this is a list. I just asked it sort of what were the list of World War II battles. But it's produced the answer. But now the question is, I could even do something like, let's see, GeoList plot, for example, of that. And it should hopefully go away and try and plot them, actually, in a sense, on the world. So it's got a computable data set there that it's using. And you can see that it's actually gone away and taken that computable data set and actually made a plot with a very, very simple linguistic utterance. So that's a typical thing you can do when you have computable data married to a high-level language. So let me show you another sort of example. This is unfortunately from the Bloodhound project, which I haven't heard too much about recently, but this was data from the previous land speed record. And the point is to try and analyze, what was interesting about this data in as quick a way as possible. And when we showed the team the analysis we'd done from the Thrust SSC project, they were just absolutely amazed about certain of these plots we'd done. In particular, it's the first time they'd ever seen the back of the wheel break the sound barrier in an actual plot in 20 years of having the data. So if you've got high-level computation allied to data, you can often get insights that are very, very new, even to people who've really been looking at that data for a very long time. So one of my arguments is that one of the ways to empower people with data is you need to get as close to the people with the, so to speak, the tool sets. You need to remove the barriers between the decision makers and insightful data. And if you think about many, many years ago, I mean, in Wolfram, for example, we had a library department. And if I had a question I wanted an answer to, I would go away and ask somebody to find it out for me. If it's very complicated, I might still do that. But usually I just type it onto the web, right? I find the answer. It doesn't matter if I'm the CEO or not the CEO. That's just what you do. Same thing should be happening with high-level data interrogation, with data intelligence, with computational intelligence. The CEO or the specialist, both should have an interface to that data they can directly use. And that's sort of a crucial aspect, I think, of unlocking data. And when we do unlock data, we can change the way we make decisions. It's interesting to think about how management decisions get made often today. So traditionally, management decisions were kind of, there weren't too many numbers in. This looked like a good plan, or this other thing looked like a good plan. Now we tend to have simple targets, simple metrics. If this hospital has 10 metrics it's hitting, it must be a good hospital. Problem is, as we all know, that doesn't work very well, because hospitals, for example, or any organization are complicated, and if you just stick 10 metrics there, you'll probably not get a good result, because you're hitting the metrics, but not what you really want. So what you really need are agile metrics. You, in a sense, need a computable data set that, I keep using a hospital as an example, but it could be any organization, is producing. And the person who wants to find out how it's doing can ask the question they want. They can interrogate the data themselves, rather than being handed a metric that somebody else wanted to produce. And there are many ways that this can be manifested. This was an example, actually, from many years ago. This was a House committee hearing in Texas. And the person, the professor involved, was saying whether they should buy hurricane insurance or not. Was it worth a state investing in hurricane insurance? Or was it a waste of money? And it's quite interesting what he did. He presented this exact notebook, and he actually got them in the meeting to start arguing about where these sliders should be. So you can actually live model things in a meeting. You can actually ask questions of the data in the meeting, in the decision-making meeting. And that's a very powerful thing to do relative to what we traditionally do at the moment, which is much sort of, let's take a few examples that somebody's pre-decided, and let's pick between those examples. So what's preventing us in most places doing this high-level decision-making? Well, there are a few things I've written here. I think one of them is a monoparadigm approach. We keep fixing on, we need to use machine learning for this problem before we even know what the problem is. Let's get the problem first, then figure out which of the ways we might solve the problem, and let's deploy those ways to get the best solution. So that's one issue. Automation between methods and things is very important. Another thing I've put right in the middle here is trust. Kind of an old-fashioned idea. But in the end, you've got to trust something. You've got to trust your machinery to the extent that you can use it. But trust doesn't mean blind trust. You've got to understand where things go wrong, and you've got to be able to have some ability to question it. And I suppose those things can all be summarized in sort of three categories of issue. The back-end data has to be in a computable form. Most people's data is pretty uncomputable. It's even sometimes made for humans to look at it directly. That's a mistake. The other thing is you need a sort of technology ecosystem that can deploy all these paradigms onto the data. So not just one way of doing it, but many, many different ways. And the other thing I've been working on a lot is that you need the human to be in shape as well. But just taking these quickly in sequence. When you think of how data automation happens, there are a sort of number of different ways out there. There's search. We're very familiar with that. There's what I might call AI curation. Watson was well known for that originally. Somehow the computer can just read stuff. There are some very specific areas where that works, but mostly that is not, for a general purpose, working very well yet. And then there's what we call computable data, where you get the data more in a computable shape, and then you kind of work from it. And you can get great new knowledge insights, and it works particularly well with anything that's at all quantitative. So one question you might ask is, how computable is your data? If you think of your organization's data, and what we've ended up doing is building a sort of Wolfram, in a sense, a Wolfram index of computability for data. And we can find this on the web, but this is about a 10-level step of data computability. Can you have natural language query the data because the data is ready in shape, it has meaning attached to it, it's computable? Or is it somewhere down this list, further down? So here's an example. This is using our computable data sets. So I'm going to try to look up in the human genome. I'm going to pick a length that I think is about right. And I'm going to try and do a lookup of that gene sequence in the human genome. And if I've made it too short, it will, it found it in lots of different places. It's a bit of a game to figure out how long to make it. But those are all the places in the human genome where that particular sequence shows up. So it's amazing I can do that off my laptop computer with one line of code and basically just query it. But that's because the data's in shape, we have a high-level language, we're ready to roll. And it's amazing. If you'd asked a few years ago, people didn't even think you could sequence the human genome, let alone call it up so quickly. So what we're advising organizations to do is build what I would call a computable data layer. In a sense, what you want is you don't want the data going directly to your experts for a human to go interpret it for the people in the organization. What you want is a layer which sort of sucks the data in and curates it. And obviously, if you have standard feeds and things, you can basically do this work once and have a curated data feed out. And then you can get much better results. You can get linguistic querying, you can get APIs, you can get computable documents, all sorts of things that can come out of being able to do that. Now, I'm very pleased to say that that message has gone to many people, and including Microsoft. And right around now, Microsoft are launching the enterprise version of Excel, which includes Wolfram Alpha knowledge query integration. So if you, I don't know whether it's actually out today on the enterprise, I know it's been out on home editions for a little while, but fundamentally, if you go into it, and I'll try and see if I can play this briefly, but you can attach meaning to the data in Excel. And you can see that here, quite sure why it's got the pause button on the middle, but anyway, we can query, there are various modes in which you can query the data directly out of Excel, and it goes off and makes an alpha query so that you can actually type and get new things in. So this is a very good example where Microsoft have seen the power that can be brought by having curated computable data that we've worked how to do with the Wolfram Alpha project. Oh, by the way, as I mentioned earlier, so have Apple with Siri, of course, as I demonstrated, that's been around for some time. And the idea that you can query is, again, a back-end result of having computable data. But of course, it's not just Apple and Microsoft. Everybody can benefit from this, and we're very much here to help with that. So what is Wolfram? What do we do? We're basically a unified infrastructure for injecting computation everywhere. That's what we've been trying to do for many, many years. And there are many facets to this. I mentioned data. The other one which we wanted to come on to is technology. One of the problems is, in order to achieve this, you need coherence. You really need a coherent language and data set to be able to do what I'm talking about. And one of the issues is, some of the open source business models don't really allow that. They work very well for some kinds of things, but they don't work very well for computational data structure and computational intelligence, because you need real coherence over a huge number of different objects, and it's very, very difficult to get that with many, many different people working on it at once. So this thought was a good cartoon to represent that. You also need what I would call multi-paradigm. You need to have all the methods, all the algorithms ready to roll, so that, as I said earlier, you can pick the method after you've known what your problem is, not the other way around. And very few systems offer that, and don't offer it coherently. So for example, going back to the open source issue, you can find the algorithms, but they all work in a very different way. They don't structure centrally, so you can't just roll from one algorithm to another as you wish very easily. You have to restructure your code often to do that. And there are many areas where multi-paradigm, I think, is important. Computation itself, do I want machine learning for this problem? Do I want traditional algorithmic approaches? Data science, interfaces, as I showed, and also language. So you need multi-paradigm for all of those things, but you need one representation for absolutely everything. And we have that. It's called Wolfram language. And the reason I've put 3 wolves up here is because Wolfram language is really 3 things in one. Whoops. It's, in a sense, a programming language, in the way that you might find other programming languages. It's also a sort of representation of all of computation, whatever it is, data, notebooks, text, sound, they're all represented in a systematic way. And it's also a way to communicate sufficiently high level that we have many advanced users, for example, who can just look at a piece of code and say, okay, I understand what this is trying to tell me, without actually running it. So those 3 are the really important aspects of having a computable language. And just to show you this is a whole bunch of different things. On the left is is the interpretation, and on the right is the inner code. And you'll see everything, whether it's graphics or 3D graphics or sound or molecules, they're all represented in the same systematic way. We are absolutely unique in being able to do that. And even this notebook I'm using here to present this, it's just simply a symbolic expression. It's a piece of text. So we have a uniquely unified platform between data, algorithms, linguistics, notebooks, and the language that kind of wraps around all of those things. And I just wanted to show you, I think I'll do this on here. I just wanted to play a few seconds of one of the consequences of this for a bio lab that does experiments. Hopefully you can hear this. Is the sound up? me, whoops. Not sure if you can hear that. Can we turn it up a bit? Okay. What they're describing, yeah, it's a bit difficult. It's maximum? Okay. It's on maximum. Okay, well. What they're describing here is that they've got everything integrated fully, from the representation of the experiments they're doing, to the actual data representation afterwards, to analyzing the experiments, and actually, as they're just going on to say, even to making the machinery do its work. So they started doing this project thinking they would just take information in, do the experiments, but now they've actually got it controlling the whole actual lab. And it's rather, so you can now basically type this on the web, and it goes and actually does the experiment for you, all coded in our same Wolfram language. So the fact that you can go between all of these different aspects is a sort of critical thing that we are trying to achieve. Okay, so a few minutes. My passion, apart from the technology, is what we do about fixing the human. We have a real problem at the moment because the humans are not keeping up with what we require of them in this AI age. And to cut a very long story short, we are trying to build a core computational curriculum that assumes computers exist. No country in the world has done this extraordinarily. And maths is right at the center of this problem. We get our kids to learn maths for 10 years of their life at school, doing things like solving quadratic equations by hand, which, as far as I know, nobody really does outside school. And the issue is, how do we reset that so we have a real sort of core computational subject that empowers our kids going forwards and doesn't just grind everybody through this relatively pointless math subject that we have. So in fact, I have spent, so my view of this is we have to have a core computational thinking skill that is kind of core at very many levels, just surviving in a modern society. You know, do you have vaccinations? Do you not? How do you understand that just as a normal citizen? And also right up to sort of, value add. You know, how are you the most productive person in society? All of those need an element of computational thinking, or I would call it computational literacy. A bit like you wouldn't hire somebody now who can't read and write. You shouldn't hire somebody in the future who can't computationally read and write, can't be computationally literate. So the question is, what is the issue and what's gone wrong? Very briefly, when you do mathematics or computation, you really do these 4 steps: define problems, abstract them, compute them, and interpret them, roughly speaking. Well, unfortunately, in school, in education, we spend almost all our time doing step 3 by hand. And we don't do almost any of the other steps. And we need to fix that. We need to rebalance it, get computers to do what they're good at, computing, and get the humans to do the other bit. So I just wrote a detailed book about my proposal for this called The Maths Fix. And in it, I'm laying out the problem as I see it, the fix, and also how we achieve change in different parts of the world. You never know, possibly even in the UK one day. Wonders could happen. So we need to avoid this computational divide. We need to achieve computational literacy. And by the way, I don't think this is just something for kids. I think you can do this in your own organizations. We've been starting to work with many organizations where they need their current adults, so to speak, to be good at computational thinking, and it can really move forward what they're doing. So just to summarize, big data was about scaling answers to a few questions. I think computational data intelligence is about scaling the questions from which you can get answers. So there are a huge number of questions out there that are too fuzzy, too unstructured, too complex, too qualitative at the moment for us to get good, solid data science kind of answers from. And I think the challenge is how to move many more of those into a realm where we can actually get good answers. It's easy to produce a number. Anybody can produce a number. The question is whether it's a useful number, a useful decision-making tool. And what we've been trying to do at Wolfram is sort of build the only hybrid technology and services computational intelligence company. So as well as building technology, we also do services, and we don't really care which we're helping you with. So if you want to just get us to do a whole project for you, we're happy to do that. If you want to get us to just get you some technology, which we think is the top technology for doing this, we're very happy to do that, or any mixture. And we're finding a lot of organizations are excited about this middle ground, that they can get started off, for example, with a piece of consulting or a project, and then they can use the technology themselves because it's easy enough to use. So, thanks very much indeed. See us at stand 743, just through there. And if you want to look at this talk in the cloud, you can get it, I think, from that QR code. Thanks very much.